What if you could control a computer with just your thoughts? Or what if an AI could suggest a thought directly to you? This isn't science fiction anymore. It's happening right now. The line between the human brain and artificial intelligence is blurring as we speak. This is the era of brain-computer interfaces, a technology that promises to change, well, pretty much everything. And it starts with the very idea of what it means to have a private thought.
And that, right there, is the central question, isn't it? As this tech goes from the lab to the real world, that dividing line between us and the machine, it's getting incredibly hazy. We're talking about a direct connection from your mind to a computer, and that forces us to ask a really fundamental question. Who or what is really in control?
The promise of this technology is just staggering. Seriously, imagine a world where paralysis is a thing of the past, where blindness can be cured, where you could learn a new language in an instant. These are the incredible things on the horizon. But with all that promise comes a really dark side. We're talking about ethical dilemmas so profound that we, as a society, are just barely starting to wrap our heads around them.
Okay, so to really grasp the risks here, we need to get how this technology actually works. Because not all brain-computer interfaces, or BCIs for short, are created equal. In fact, there are two totally different ways of building that bridge between our minds and machines.
On one side, you've got your non-invasive BCIs. Think of these like headsets that just read your brain's electrical signals from the outside through your scalp. They're safe, sure, but the connection is weak. It's kind of like trying to hear one person's whisper in a packed football stadium. But then you've got the other side, invasive BCIs. We're talking about chips and tiny electrodes implanted directly inside the brain. The connection is unbelievably powerful. And here's the crucial part. They can not only read your thoughts with high fidelity, they can also write information back to your neurons, maybe even change them. And that's where the real magic and the real danger truly begins.
For a lot of people in this field, this is the end game. A completely seamless symbiosis where you honestly can't tell where your own biological thought ends and an AI suggestion begins. And it's right at that point of indistinguishable fusion that these massive ethical problems really snap into focus.
So, because of this looming threat, ethicists and scientists are scrambling. They're proposing a whole new legal framework to protect what you could call the final frontier of human privacy, our own minds. They're calling them Neuro-Rights, and we're going to need them fast.
Here's a really powerful way to think about it. All our current privacy laws, they protect our actions. What we search for, what we buy, where we go. But neuro-rights, they're designed to protect something way more fundamental, our very essence. What we think, what we feel, who we are before we even decide to act. Let's break down the 5 big ones they're proposing.
First up is mental privacy. Now think about this. If a BCI can read your mind well enough to move a cursor across a screen, what else can it read? It can probably infer your subconscious desires, your secret fears, your political leanings. This opens the door to something called brain mining, where all that raw thought data could be packaged up and sold. Can you imagine getting an ad for something you didn't even realize you wanted, but your brain activity gave you away?
Second, we have personal identity and agency. And this one cuts right to the heart of free will. If an AI that's wired into your brain suggests a thought or just gently nudges you away from an impulse, who's really making that call? At what point do you stop and the algorithms start?
Third is cognitive liberty. Basically, your right to control your own mind. But picture a future workplace where all your colleagues are augmented, making them 10 times more productive than you. The pressure to get an implant just to stay competitive, just to keep your job, would be immense. All of a sudden, that choice to stay purely biological doesn't feel much like a choice at all, does it?
And that leads us right to the fourth right, which is fair access. This quote just nails the stakes. If cognitive enhancement is super expensive, we could literally create a permanent biological divide in humanity. A new class of augmented humans with high-speed AI minds, leaving everyone else, the biologically obsolete, far, far behind. It is a genuinely chilling thought.
And finally, number 5, protection from algorithmic bias. The AIs that translate your brain signals into computer commands, they have to be trained on data. But what if that data is biased? What if it's trained mostly on one demographic? The system could end up systematically misinterpreting the intentions of people from different backgrounds. This could create a whole new, insidious kind of discrimination, baked right into the tech that's reading our minds. So we've got these massive ethical dilemmas. But beyond all that, there's a much more immediate, much more visceral threat we need to talk about. And that's hacking. Because let's be real, if a device can connect to the internet, it can be hacked. And when that device is your brain, the stakes are just higher than they have ever been before.
Because when the computer is your brain, a cyber attack isn't about someone stealing your credit card info or your password. No, it's about something way more terrifying: the fundamental manipulation of your perception, the manipulation of your actual reality.
Security experts are warning about two main ways this could go down, two primary forms of brain hacking. And frankly, they're both pretty nightmarish.
First, there's what's called sensory hijacking. This is where a hacker injects false signals directly into the parts of your brain that handle sight and sound. Just imagine it for a second. You could be made to see a flashing red warning light on your car's dashboard that isn't really there, or hear a voice whispering things that don't exist. The potential for manipulation is just off the charts.
The second type of hack, and maybe the more insidious one, is behavioral modification. This is where the hacker subtly alters the release of chemicals in your brain, like dopamine, to nudge you. A tiny nudge toward buying a certain product, or voting for a specific candidate, or maybe even becoming addicted to the BCI itself. It is the ultimate form of mind control.
So with all these insane threats on the table, what are we doing about it? Well, the biggest problem right now is a massive legal vacuum. The law just hasn't come close to catching up with the technology.
And here's the core of the problem. Right now, if a BCI is used for a medical purpose, like helping someone walk again, it's regulated like a pacemaker. It's very strict. But the second a company markets a nearly identical device for wellness or enhancement, say a headset that promises to make you focus better, it falls into this huge legal gray area with almost no oversight at all. So what can we do? Well, experts are pushing for three key solutions to plug this gap. First, create a whole new data class for neurodata. Don't treat it like your search history, treat it like biological tissue with the same legal protections as an organ donation. Second, strict decoupling. The company that makes the BCI hardware absolutely cannot be the same company that analyzes your cognitive data. Build a firewall between them. And third, man data kill switch. A real, physical, hardware-level off switch that guarantees the user always has the ultimate control.
And this quote just says it all. The urgency is real. We cannot be reactive here. We can't afford to wait for the first catastrophic mind hack to happen before we finally decide to pass these laws. We have to codify the sanctity of the human mind right now, before it's too late.
Look, the integration of our minds in AI is coming. It's not a question of if, it's a question of when and how. The real challenge isn't just a technical one, it's a deeply, deeply human one. As we expand what our minds are capable of, we have to figure out what we are not willing to sacrifice. And the question that leaves us with is this: what part of being human is not for sale?